Along the northern edge of China, where the land dissolves into endless dunes and the wind reshapes the horizon day after day, lies a desert that was once considered completely uncontrollable. The Kubuqi Desert, located on the Ordos Plateau near the Yellow River, stretched across thousands of square kilometers as one of the most hostile landscapes in the country. Rainfall was scarce, temperatures were extreme, and the sand itself was constantly in motion, swallowing roads, villages, and farmland without warning. For decades, the desert advanced relentlessly. Sandstorms intensified year after year, darkening skies in nearby cities and disrupting transportation, industry, and daily life. Entire communities were forced to relocate as productive land disappeared beneath shifting dunes. The desert did not merely resist development, it erased it. Yet instead of retreating, China made a decision that defied conventional wisdom. Rather than abandon the Kubuqi Desert, engineers, scientists, and local communities chose to confront it. Not with a single dam or canal, but with a long-term system of smart irrigation, sand stabilization, ecological engineering, and digital monitoring. What followed became one of the largest desert reclamation efforts ever attempted on Earth. This is the story of how China turned the Kubuqi Desert green, when desertification became a national threat. The Kubuqi Desert is not an isolated wasteland. It lies close to major cities, transport corridors, and industrial zones in northern China. As desertification accelerated, the consequences spread far beyond the desert's borders. Railways were buried repeatedly, highways required constant clearing, agricultural losses mounted as sand encroached on fertile land. Air quality deteriorated across entire regions as dust storms carried fine particles hundreds of kilometers away. What had once been a regional environmental problem became a national economic and public health concern. Traditional responses failed. Tree planting campaigns collapsed as saplings died within months. Irrigation attempts wasted precious water that vanished into loose sand. Heavy machinery could not halt dunes that reformed with every strong wind. China needed a fundamentally different approach, one that treated the desert not as an enemy to be conquered, but as a system to be stabilized and managed. The core insight: sand must be controlled first. Engineers reached a critical realization early in the project. Water alone would never defeat the desert. In loose dune systems like Kubuqi, pouring water without controlling sand movement simply accelerates evaporation and erosion. Before irrigation, agriculture, or vegetation could succeed, the desert itself had to be immobilized. The first phase of the project focused entirely on sand stabilization. Workers laid vast grids across the dunes using straw, biodegradable fibers, clay, and later synthetic materials. These grid patterns broke wind flow at ground level, preventing sand from shifting and trapping moisture in small pockets. What appeared simple was, in fact, a carefully engineered solution rooted in fluid dynamics and soil mechanics. Once the sand stopped moving, the desert stopped advancing. From moving dunes to stable ground, with wind energy reduced at the surface, the stabilized dunes began to behave differently. Moisture lingered longer after rare rainfall. Temperatures at ground level dropped slightly. Organic matter no longer blew away immediately. This was the first transformation. Invisible to the eye, but critical. The desert was no longer a constantly shifting surface. It became a platform upon which further engineering could begin. Smart irrigation in a land without water. Water scarcity remained the greatest limitation. Flood irrigation was impossible. Any large-scale reclamation would fail unless water could be delivered precisely, efficiently, and sustainably. Engineers deployed drip irrigation systems across reclaimed zones, delivering water directly to plant roots at extremely low flow rates. These systems minimized evaporation and eliminated runoff. Underground pipelines reduced heat exposure, while pressure regulators ensured uniform distribution across uneven terrain. Solar-powered pumping stations supplied energy in remote areas, allowing irrigation systems to operate independently of centralized grids. Soil moisture sensors fed real-time data into control systems, ensuring that water was applied only when absolutely necessary. In the Kubuqi Desert, every drop mattered, choosing life that could survive. Instead of forcing traditional crops into the desert, scientists focused on native and desert-adapted species. Plants were selected not for immediate productivity, but for their ability to survive extreme heat, drought, and poor soil. Species such as desert willow, licorice root, and hardy shrubs were introduced. Their deep root systems anchored sand, reduced erosion, and gradually improved soil structure. As roots penetrated deeper, they increased water retention and allowed microorganisms to return. Over time, the soil itself began to change. What was once sterile sand slowly transformed into a living medium capable of supporting complex plant life. Building green corridors through the desert. Rather than attempt to reclaim the entire desert at once, planners adopted a phased approach. Green corridors were established, long, continuous strips of stabilized and vegetated land that cut across the dunes. These corridors acted as both windbreaks and ecological anchors. They reduced sandstorm intensity while providing connected habitats for vegetation to expand outward. As each corridor stabilized, adjacent areas became easier to reclaim. From satellite imagery, the transformation is unmistakable. Where once there was uninterrupted sand, long green bands now carve through the landscape, evidence of engineering reshaping geography itself. Infrastructure, industry, and economic survival. For the project to last, it had to sustain itself economically. Reclaimed land was integrated into broader regional development plans. Medicinal plants grown in desert conditions became high-value agricultural products. Controlled livestock grazing provided income while preventing overuse. Solar power installations transformed stabilized zones into renewable energy hubs. The desert was no longer treated as wasted land. It became productive, regulated, and economically relevant. This integration ensured long-term funding and local participation, two elements essential for success at this scale. Digital monitoring and predictive control. Modern technology played a decisive role. Satellites tracked vegetation growth and sand movement across vast areas. Drones surveyed erosion hotspots and irrigation performance. Data from sensors fed into predictive models that allowed engineers to anticipate failures before they occurred. Instead of reacting to desertification after damage was done, the system shifted toward prevention and control. The desert was no longer unpredictable. It became measurable. When the desert began to change. As vegetation expanded, secondary effects emerged. Wind speeds near the ground dropped significantly. Sandstorms weakened. Soil temperatures stabilized. Moisture retention improved. Local communities returned to areas once abandoned. Roads and railways previously threatened by sand became reliable. Agriculture expanded cautiously, supported by data rather than guesswork. The desert did not disappear, but it stopped advancing. And in desert engineering, containment itself is victory. The scale of the achievement. Over several decades, thousands of square kilometers of land were stabilized and partially reclaimed. What began as experimental plots evolved into one of the world's most extensive desert control systems. International organizations studied the Kubuqi model as a blueprint for combating desertification in Africa, the Middle East, and Central Asia. It proved that large-scale restoration was possible, even in extreme environments, if engineering, ecology, and economics were aligned. Limits, costs, and reality. The project was not without limits. Water scarcity remains a constant constraint. Maintenance is continuous. Not all land can be reclaimed, and not all vegetation survives long-term climate variability. But the goal was never to eliminate the desert entirely. The goal was to stabilize it, coexist with it, and prevent further damage. Engineering with nature, not against it. The success of the Kubuqi desert transformation lies in its philosophy. Instead of overpowering nature, engineers worked with natural processes: wind, roots, moisture, and time. It was not one megastructure. It was millions of small, coordinated interventions. Together, they reshaped an ecosystem. So now you've learned how China turned parts of the Kubuqi Desert green, not by forcing the land to change overnight, but by stabilizing sand, controlling water, and allowing life to return through patient engineering. Do you believe large-scale desert reclamation like this is the future for arid regions around the world? Let me know your thoughts, and join me for the next story of human engineering reshaping the planet.